All right, so today we're going to be going over NumPy and Pandas. I go through importing in Python libraries, and then go through identifying the differences between NumPy and base Python, and I will also be introducing Pandas. So first thing I wanted to go through is importing Python libraries because I think this is going to be our first introduction to any Python libraries. I know in the prep course you went through Pandas and you went through some plotting libraries, I think Plotly, but let's talk about how to import in a library to start. So to import in a library, you type import and then the name of the library. So in this case, I'm importing in NumPy, and then I'm making a NumPy array. So dot array is a method within the NumPy library. If you do NumPy dot and then type tab, you'll see all the different methods associated. And I use the array, you can see that. But there's literally, I don't know if there's thousands, but there's probably close to that number of different things that you can do in NumPy. I'm going to show you some of them. And you see this kind of looks like a list, but if we check the data type of it, it's actually a NumPy array. And there are some advantages of having NumPy arrays instead of Python lists, and I will talk about that. There's also a way to import a library where you use an alias. So instead of having to type NumPy each time, you can set an alias of np, and then you can type np.array. So it saves a little bit of typing. And you'll almost always see people use import NumPy as np. It's a good practice to have. And nice thing with NumPy, you can take, there's a lot of mathematical operations that you can do with a NumPy array that you can't do with a Python list. So here's some different libraries: SciPy, Pandas. See, Pandas has an alias, and Matplotlib. Matplotlib is a really common library for plotting, and it's the library that I end up using the most. So if we run that, we can make a plot, and pretty simple so far. What I like about Matplotlib is you can set different styles. And we'll cover this, I think next week is when we go into the plotting, but so just a single line, we make our plot already look much cooler. You can do ggplot, this is another one, and another different style, and I always do plot.xkcd. I always like this style because it looks hand-drawn, which I think is kind of cool. But you can always, we will be covering this a little bit more in depth next week. So next, try importing in the Seaborn library as SNS. So if I was going to do that, how would I do this?
As SNS.
Okay. Perfect. So now I can utilize all the things inside of this, the Seaborn library. So yeah, great job. And SNS is a pretty common alias for Seaborn. Seaborn's a plotting library, which we will cover a little bit more later on. So nicely done. So what happens if we mess with naming convention? So if I do this, so import pandas as print, and this should be a red flag. So anytime we name a variable or name a library, something that shows up as green, this means this is a protected word in Python. So I'm going to do this, so let's say I want to print something now. I want to print hello. What do you think is going to happen?
Well, it's thinking that it's trying to execute the pandas library.
Exactly. Yeah. So I no longer have access to print stuff. So it says the module object is not callable. So I'm going to comment this out. If you do something like this, comment it out, and then go to kernel. And you do restart and clear the output. I'm going to run all above this cell, and let's print hello now. So hello works. Cool. So I'm going to include this notebook in the link for the video. I haven't had a chance to put up the video from last night, but I will put it up there, and I'll include the notebook. But this notebook will be in the description of the video. So here's some different libraries. Numpy and Pandas, that's what I'm covering today. I'm almost positive visualizations are next week, and I kind of want to check real quick. Yeah, so we're doing 3 and 4. So we're doing data cleaning, which this is going to be more pandas, and then 6 is data visualization. So you'll learn more about matplotlib and just matplotlib next week, and SciPy you'll learn more about, and it's pretty heavy in mod 3. So that's just a little high-level overview of how to import into libraries into Python. And if you remember when we installed the Learn environment, so we were setting up a professional data science environment. So this lab, this is where you created the Learn environment. So if we go to the GitHub, I'm on a MacBook. So when I created this, I used this environment.yaml file. This has all those libraries. So when I imported in Pandas, I imported in Pandas 0.234. When I imported NumPy, it imported just this version of NumPy, not a specific version. When I did matplotlib, this is the version. So this is why you're able to import all these things, because you downloaded them when you made the Learn environment. But let's talk about some NumPy now. So now that we know about libraries, let's kind of use some of these libraries. So Python has lists, and normal Python can do what's kind of basic math. However, NumPy kind of takes that to a next level. NumPy is a little bit more efficient computationally when you're going to be doing some large math. Anytime you're going to be doing any sort of like math, I would recommend using a NumPy array. So right here we have 2 lists. This is a base Python list, the names list, and then we also have a names array. Character array in NumPy, this will store strings, which is what these all are. So we can do both operations in Python or NumPy. So NumPy is really good when you're doing math. You're typically not going to be doing a whole lot of math operations to strings. So I would probably recommend just using a base Python in this. But going a little bit further, if we have a Python list and a NumPy array, let's try and divide the Python list by 2. We're able to do that. And then this is the Python, or this is the NumPy array, I'm sorry. So this is the NumPy array, it works. The Python list, this should throw an error, and it does. So we can't do a lot of mathematical operations with a base list. This NumPy array, you can do all kinds of mathematical operations. And what you'll find is that as we get into machine learning, you're going to be doing a lot of what's called matrix operations, and everything will be in these big NumPy arrays. The advantage with NumPy is it is very fast computationally, and it works well with pretty much any mathematical operation. Um, so there's all kinds of things you can do with a NumPy array. You can look at the shape. So this is 4. We could also make a multi-dimensional NumPy array where think rows and columns of a CSV. So if we had np.array and 1, 2, 3, 4. So if we have an array like this where there's 2 rows and 2 columns, we can have that. So now it's a 2 by 2. And you can also have 3 dimensions.
Question.
Mm-hmm.
Can I raise my hand really quick?
Yeah,
so
yeah.
I see when you're formatting that, you go NumPy array, and then there's one set of parentheses. There's another set of parentheses. There's 2 set of tuples. Slow that scroll for me really quick. Explain why you're setting it, like embedding it twice.
Yeah, so I'm wanting to get a multi-dimensional array. So the first square bracket is for the entire, wraps around the entire array. And then the second square brackets, these inner square brackets, are wrapping each row. So this is row 1, which is 1, 2. And then I have a second set of square brackets, 3, 4, that separates the next row. So if I did...
Oh, I get it. Okay.
Yeah, great question. So if I do another comma and another set of square brackets, where is the 5, 6 going to show up?
Next row, right?
Next row, yeah. Exactly. Yeah, and feel free to stop me anytime with questions or anything. Selection and assignment work as you might expect. So let's look at numbers array again. Numbers array. So it's to grab elements out of an array exactly the same as a list. So this is the second element. NumPy arrays are 0 index. So if we do 0, we can get the first element. If we want the last element, we can get the last element with -1. So exactly the same as a Python list. We can also
another question came up. Sorry. To set the array, so how does it know? Like in base Python, you do, when you're setting I think of it like as a variable. So right there on line 18, for your input 18, NP array is where you're defining it, right?
Mm-hmm.
So would you call it, like, let's say you wanted to do a different one, would you put like a 1 on the end or something like that? Like if you're going to do another array? Am I going too far?
So in this specific case, I name it as a variable. So I can't use it anywhere. But if I wanted to use it, I would need my array or something. Now I can reference my array. But
okay. But you're just using this as an example. I'm sorry, my mind races
no.
to the next step. So I just wanted to know how you defined the array, and it's pretty simple, and I'm just breaking it down to like the nuts and bolts of it, which is in line now 25, NP array, and then that's when you set your array. Okay, thanks.
Mm-hmm. Yeah.
But Jeff, on my array, if you indexed it to 1, that's going to give you 3, 4.
Yeah, let's take a look.
All right.
Very nicely done. Now, if I wanted just 3, how would I get just 3?
1, and then open bracket 0, close bracket.
So like this?
Yeah.
Yep.
I think.
Does that make sense?
No.
So I've got the second row, first element. The second row is.
Oh, yeah.
And first element, that is 3. Very nicely done. So let's look at the numbers array again. We're going to change an element. So element 1 right now is 22. Now we're going to set element 1 equal to 10. So now it changed it to be 10. So this is exactly the same as in a Python list. You can do the same operation. And yeah, any questions about this?
Does the Numpy array also take append or no?
That's a good question. Honestly, never tried that. Numbers array dot append 14.
Nope.
It doesn't. Yeah, typically when you'll start with a NumPy array as you'll read in like a CSV or you'll read in some SQL, so you'll already have all the data. I don't know how to append. I want to look that up real quick. That's a great question.
So I guess the question is, how do you append? Do you append to a NumPy array or no?
Well, usually you will. Usually you can just add to it. I want to do a quick Google because I don't want to lead you down a wrong route. Yeah, they do have an append. It's a little bit different. So we could do numbers array. We could do maybe 4.
Oh, okay.
Yeah, so it's a little bit different syntax. But yeah, that was it.
But then you broke your pattern, right? So they're not, oh, never. I thought they were in pairs. But I was working off the prior example.
Oh,
Sorry.
no worries. But yeah, I could do the same thing with my array too, but I would need to put in multiple elements. Looks like I might be losing my. Yeah, you lose the shape when you open.
Yeah, then you lose the shape.
That's interesting. Yeah. So if you're gonna append to it, it looks like you have to be a little bit careful with how you append. But I can honestly say I don't think I've ever used this NP append in any time working as a data scientist. So I wouldn't be too concerned about it. Any questions about that before I move on? All right. So next we're going to go into some array math, and this is kind of what is really great about NumPy is all the array math. So if we have 2 arrays, let's just print these out above. So X is 1, 2, 3, 4. Y is 5, 6, 7, 8. We can add them together. And I'm going to show multiple ways. I think I'm going to show 2 ways to do all this. You could just do X plus Y. Then there's also np.add. Reason I'm showing both ways is that both ways are pretty common. So that if you see both ways, you know that they're doing the exact same thing. So you can literally just add the 2 NumPy arrays together, or you can use np.add. You can do the same thing with subtraction.
Oh, wait, I have a question.
Mm-hmm.
So you know how sometimes when you print stuff out in Python space versus returning it, like let's say in a function, you get a list versus, so the data type changes? Oh, you're still asking it to print. I'm sorry. I answered my own question.
Okay, yeah, no worries.
I was wondering if it changed the data type.
No, the data type will simply do. So it's still a NumPy array, and if we do type of this, give me all my parentheses. This will be a NumPy array too. So the data type's not going to change. So if we subtract, same thing with np.subtract. imagine you can kind of see where this is going. If we multiply, we can do x times y, multiply x and y. We can divide. Divide as well. And then we can also take the square root. Any questions about that? So next I want to go into pandas. Pandas is probably my favorite library in Python. It's the library that I used more than any other library at my last job. And it's, for one, it's built on top of NumPy, so it uses a lot of the same commands. And it's just I think it's a really fun library to work with. So why use pandas? If you have to load in any data from a CSV, a TSV, which stands for tab separated values. So if it's not comma delimited, but there's a tab delimiter, or it's an Excel file. You can also read data from SQL, which we will learn about later on, which is a really, really common database in industry. It's really easy to work with, really easy to load in the data, and it's really easy to do some really cool things with. So to start, I'm going to import in pandas with the common alias, which is PD. If you type ls in the terminal, or not in the terminal, the cell here, it'll run the terminal command ls. So if you see here, these are all the files in my current directory. So I have this example1.csv. I have a made-up jobs.csv, and I have a map zip New York City hood.csv. So I think I'm going to be loading in all those in a little bit. The main thing in pandas is called this data frame, and data frame is used for loading in structured data. What structured data is data that has set columns. So if anyone's worked with Excel, Excel has set columns where each observation has to have something in that column, whether it's a string, whether it's a float. It could also have a missing value if there's nothing in there, but it has to have that. An example of unstructured data is text data. It could also be like image data, which you'll learn about in module 6 on using neural networks to kind of process this. If you're ever confused about a particular library, so if we did np.array and did a question mark, it pulls up the documentation for the NumPy array. And so it gives you some like information about it. It's usually a good thing to kind of check if you're like really confused about it. Let me close that. Instead of, you could also Google it. NumPy array. And I personally prefer to look at it on a website versus this, just because I think it's a little bit easier to read. But if it's something quick, this is just a really quick way to like find it. Really nice. Close that again. And we're going to be using the pandas data frame. So to take a look at that, here's the documentation for a data frame. And just to look at it on the website as well. Pandas data frame. So when I'm looking at a documentation like this, so I'm looking at what the parameters are. So these are all the different arguments that you could put into the pandas data frame. So I need to specify data, and the default argument. Some of them have default arguments. So copy the default argument, excuse me, is false. The data type is none. And some of them just specify none. I'm going to be loading in a CSV here shortly. And another way to get help, you could also, if the small documentation, you do it twice, it makes it a little bit larger. Again, quick way to kind of look at documentation. I personally prefer to just go to the website, but everyone has their own kind of preferences. So the first thing I'm going to be doing is reading in a CSV. This is going to be a really common operation. So it is PD, which is, this is the alias for pandas, and I'm going to be using the read CSV method, and I'm going to be loading in this CSV example 1. And then now after I've loaded it in, I'm going to apply the .head method. And what head does is it prints out the first 5 rows of that CSV. And in this case, it doesn't look like there are 5 rows. Let me print out example CSV, the entire thing. Yeah, so if I print out the entire thing, there's only 2 rows. Since there wasn't 5 rows in this, it's just going to print out as many rows as there are. And what this is doing is it loaded in this CSV. And, what is this example? So this is that CSV. I see it. So it's just two rows, and this is a header row. Pandas will typically read in the first row as the header. So it knows this is the header, and then these are the different observations for each of the for the rows. So that was.
I have a question really quick. So when you import it, the file is live in your kernel where you're working, right? If you go back and modify that example CSV while you're working on it, does it update real time, or it's just a copy of it?
If I add example 1, Jeff Herman, just something, and I save it. So if I look at examples CSV, it'll still be the same. But if I reload in, run this line again, that loads in this CSV, now it shows up. So if I reload it in, it'll update.
Good to know. Thanks.
No problem. And then you can also, if there's a, in this example, we're getting a CSV from the internet. This is data from Austin, Texas. And I'm going to do .head again. So this is some information about, I think like pet rescue. But if we go to this website, I think it'll just take me to a download. I run it. Yeah, it just downloads a CSV. So some websites will allow you to load in a CSV right from the website. A lot of them will not. But this is kind of just an example where you can load it in from just using the URL. So I kind of already talked about this already. .head. This will pull out the first 5 rows. This is usually one of the first operations that I do, just to make sure that everything kind of looks as I expect it. You can specify how many rows you want to look at. So maybe I want to look at the first 10 rows. So now I'm looking at the first 10 rows. And another operation that's kind of related to this is tail. This is going to be the last 5 rows. So these are the last 5 rows in the data set. If I want the last 10 rows, I can do .tail 10. But it's a really good operation to do. It kind of makes sense to kind of take a little gander at your data and make sure it kind of is what you were expecting it to be. So now we can look at the data type. So this is a Pandas data frame. So if you remember from before, the Numpy arrays, they were showing up as np.array. So these are actually what's known as a data frame. The length and the width of our data frame, you can get that with .shape. So our data frame is 1,000 rows and 12 columns. So it's good to know. This is one of the first operations that I will run as well, just to see how large my data is, because some of these can really slow down your computer. Next, we can check the data type of each column. So we have, of those 12 columns, every single one is type object, which it means it's a string. If we look at this, let's do .head again, make it a little smaller. If I was going to be playing around with this, this date time, this probably shouldn't be a string. We probably want that to be, there's a date time data type, which will show, I think we talked about that a little bit next week in the cleaning the data. But you'd probably want to convert this to a date time if you were going to look at, wanted to like make a plot and look at this. And then this is kind of looks like it may have been like a integer or a float, but it has 2 years, 5 years, 6 days, 6 days. So the reason Pandas recognized it as a string was because it has this years option in there. But yeah, it makes kind of sense that everything would show up as an object. We can also get the data type for just a single column. So this is data type O, which stands for object. .info is a pretty useful little command. Hang
on, I have a question. Let me stop you. What are some other examples of the data types? There's like objects. Is it like integers, like floats?
Yeah.
What are some examples?
So the most common ones that I've seen are objects, floats, integers, and Pandas date time are the ones that I can think of off the top of my head.
And like object would be text, date time is a date, and then integers or floats are straight up numbers. Okay, yeah. Thanks.
Yeah, integers are no decimal. Oh, and floats would have a decimal. One more type is something called categories. So you'll learn about this in section 7 and 8 when we go over regression, but maybe they represent days of the week instead of with days, but with 0 through 6. And 0 is Sunday, and 1 is Monday, and 2 is Wednesday, or 2 is Sunday, Monday, Tuesday. 2 is Tuesday. So you can represent that as a category, so that Pandas knows that this isn't supposed to be treated as a number, but this is a category instead.
So you set whatever the value is as its own particular data type would be an example of a category. Am I understanding it right?
So I'm sorry, say that one more time.
So you kind of define the category based on what you tell it to. Like a date, time, you define as a category, or could you use like an object as a category once you do something to it to modify it in some way? Yeah, or am I fully off base?
No, you certainly could use make a object a category. Usually you'll use a number just because most algorithms will not handle objects. So
okay. But theoretically.
Yeah, you could. I wouldn't recommend it though. But it's like the idea is that some algorithm, if it sees that Saturday is a 6 and Monday is a 1, a lot of algorithms will say, okay, so this Saturday is 6 times what a Monday is, and that doesn't really make sense. That Saturday is 6 times more than Monday. You'd want to specify that it's a category, and you shouldn't try and treat it as some like sort of like linear relationship. Does that make sense? Any questions?
That answered my question. So there's essentially, for our purposes today, object, float, and integer, essentially is what we'll be working with.
Yeah.
I'll keep it small.
Yeah. Well, you will learn more about them. Really, we're just trying to get you a little bit of a taste of pandas. And then this .info is pretty useful as well. It shows every single data type. So for each column, what data type. And what's also nice is that it specifies, so there's 1,000 rows in it, and it tells you how many non-null values there are. So this one has no null values. All of them have no null values except this one. Whatever 1,000 minus 557 is, that's how many null values are in the name column. And we could take a look at that.
How do you know that there is, I see non-null. So how do you know there are null values in there? I don't understand.
Yeah, so there's 1,000 rows in each of these columns, right? And there's 557 non-null values. So if we have 1,000 minus 557, that's how many null values are in this column.
Oh, it just clicked. Okay, I see.
Another way to do that is null.sum. So there's 443 null values in the name column and 0 in everything else if you're just wanting to look at null values. So I think the rest of the time I'm really going to be going through this loc and iloc. It's really common for filtering. So we have a new data set here, and loc is for indexing by name. iloc is used for indexing by number. And I'm going to show examples of that because it probably doesn't make sense at this point. So I'm going to load in a new data set. This is New York City dogs, so information about dogs. So we're going to start with iloc, which is used for indexing by number. When grabbing something, if you want to grab a specific row or a column of a pandas data frame, you can use this iloc and reference that row or column by the number. So what does that mean? You have our data frame, New York City dogs, and then we chain on .iloc, and then if we want to grab just the first row is 0, we can use this to grab that. You'll commonly see it's specified as row, comma, column. So we want the first row, and you'll commonly see actually this, and it'll give you the same value. This is what it's saying is, I want the first row and all columns. And does this make sense? Any questions about this? So grab first row, all columns. So always remember iloc and loc. The reference is which rows do I want, which columns do I want. So if I wanted the opposite, where I wanted the column.
I do have a question, Jeff. I'm sorry. So if we unpack the code right there on line 85, nycdogs.iloc, I understand you're grabbing the first row. What does the space do between the space and the colon?
It's just for readability. If I can do that as well. I always just add a space.
And if you only wanted to grab the rows, just help me understand. If I wanted to grab all the rows, I would do :0, right?
Colon, comma, 0.
Oh, okay.
So if I wanted,
Thanks.
that's what I'm doing in this next line. So if I wanted all rows from the first column, so I would do : to specify all rows. and then comma 0 to specify I only want this first column. If I do,
Thank you.
yeah, no problem. If I do colon colon, what is this going to return?
Everything.
Right, everything.
Yeah. So it's not doing a filter on anything. I like to print out NYC docs every once in a while so I can remember what I'm looking at. I'm just looking at the first 2 rows. So if I want to return the first 2 rows, what this is going to do, and I'm going to be honest, I typically do this syntax to specify I want all columns, but you'll see that it's not necessary. So what this is showing is I want the first 2 rows and I want all columns. I will typically do that just out of habit, but you get the same results. Does that make sense?
No, slow the roll. Sorry. I understand. Maybe just repeat it again, and I'll try and get it the second time.
So what this is saying is I want the first 2 rows and all columns. And if you leave the columns blank, the default is all columns. So you don't technically need that comma colon. So this is saying I want the first 2 rows, and because I don't put in an argument for the columns, it's grabbing every single column. Is it still a little fuzzy?
Kind of. I'll rewind and watch. It's
Okay.
cool. No, does anybody else? Am I the only one that's not clear on it? If I'm the only one, I'll just rewatch it. It's not a big deal.
Well, it's giving. It's I think when I first looked at it, it looks a little strange because it looks like I'm asking for row 0, row 1, and row 2, but that's not. It's not going to give you that. It's giving you position 0 and position 1, but not position 2, right?
Yeah, it's non-exclusive on this end. So it's not going to give you that final number. So
If you put 0:1, it's only going to give you row 0.
Mm-hmm.
It's up to, but not including 1.
Yeah. Yeah, that's the same as, not to like add more confusion, is this.
So I understand correctly. So iLock is only dealing with positions in terms of numbers, right?
Mm-hmm. So loc is, we'll go to loc, but if I wanted to reference the columns by, instead of grabbing this column row number, if I want to specify, I want to grab column and put in row number, loc will handle that. iLoc just references columns as numbers.
And the first number, I'm sorry, this is new to me, brand new. So the first number represents the row. The second represents the column.
Yeah, row, comma, column.
So how come there's more than one column? And I'm sorry if that sounds like the stupidest question ever asked.
No. In this one?
Yeah, so there's more than one column.
Yeah, if you leave the argument for columns blank, which we did because there's no comma, right? The default.
Oh, okay. That's what I was missing, is the comma is what calls up how many. Okay, that's exactly what I was missing. It just clicked. Boom.
Nice.
Thanks.
So Jeff, just to clarify, if you do 0:1, comma, open quotation, animal name, you're going to get an error, right?
Yeah, it's not going to know what that is.
Because you did iLock.
Yeah.
Okay.
But if I wanted animal name, how could I
Then
reference?
you would do comma 1, because that's the position of this of animal name.
Yeah, yeah. So we grabbed, in this case, we grabbed page. So row 0, column number 1. Yeah.
Okay.
So next, what is, it kind of says here, what is this going to return?
Well, it's saying you want all the rows, but you only want columns 0 up to, but not including 2. So it's row number and animal name.
Mm-hmm. Very nicely done. And I can chain on dot head to this as well if I only wanted to preview the first 5 rows. Something that's nice about a Jupyter notebook is, so this output is rather large. It's a lot of rows. If I hover over here, you see how it kind of, there's this box. If I click on that, it'll shrink it down and it'll add a scroll bar so it doesn't take up as much room on your screen. So this one was a large output. So if it's a large output like this, I'll shrink it down. So this, oops. So this is grabbing first row, columns 1 and 2. Head. So first row, columns 1 and 2. So it's grabbing 1 row number and 2 page. So next, I'm going to move into loc. So loc is the same way. Always remember row, comma, column. So let's look at NYC dogs again. So this is going to grab that entire first row again. Then because these don't have the rows, this is called an index right here. This 0 and 1. This is not text-based, so that's why we're still using a 0. But now if we want to grab a column name, we no longer reference it as animal name is no longer a 1, but we actually reference the name of the column. So we're grabbing Paige and Yogi and Allie and Queen. And does this make sense?
Yes.
And then this is
Yes.
Okay.
It makes sense, Jeff.
Awesome.
My gosh, I was in the weeds and now I'm out. Thanks.
That's what I like to hear. And then this is a large output again, so I'm going to suppress it. And then what is this going to return? So let me pull up the data frame again. Dot head. So what will this return right here? This this command.
Row 1, column animal name.
Row 1.
So Yogi, it should be Yogi. Oh.
So it's pulling up rows 2 and 3 because you didn't include 0. If the value was 0, 1, it would have pulled up Paige and Yogi.
Mm-hmm.
But because it's 1 and 2, it's pulling Yogi and Allie.
And you probably noticed, you're absolutely right. And David, you may have noticed that you kind of thought it was just going to pull up Yogi.
Right.
Past, like it was non-exclusive. It's a little bit different with loc, where if you specify, if we want columns 1 and rows 1 and 2, it's going to actually pull up exactly 1 and 2. So it pulls up both of them. So it's slightly different.
Is that because it's working off of the index?
Mm-hmm. Yeah.
Okay.
It's actually grabbing.
So if you think of it like a matrix. Yeah. Okay.
So kind of a similar idea here. We can specify multiple columns. So we want everything from animal name. Where's animal name? Animal name to zip code. So it's grabbing animal name, animal gender, animal birth, breed name, borough, and zip code. So we can also use this colon notation to grab.
Yeah. What does the non mean?
That's a null value.
Under burrow. Oh, okay.
Yeah, so if we look at NYC dogs dot is null, I'll just do dot head. So row 1 burrow, is true, so that's showing up as a null value. It looks like all these are null values actually. So if you were going to build some sort of model or do something with that, you'd want to do something with all these null values. But not to jump ahead of ourselves again, you will learn about like data cleaning, I believe next week, on like how to deal with null values. And then I think this is the last one I have. So this is saying I want rows 1 and 2, and then I want columns animal name, and I want column zip code. Okay. So specify multiple column names as well. But any questions about that?
So to specify specifics, you use a comma rather than calling it up like a, okay, cool.
Yeah. If you have multiple column names, you'll need to specify, add it. You'll have to add a second set of square brackets around all the column names to specify this is just the columns that I want. Because it uses the comma to separate the different values, but we want pandas to know that this is all together, all these columns.
Got it.
Any questions? Okay, cool. So basically, yeah. Pandas, you'll be utilizing it a lot. iLoc and loc are very commonly used for filtering data frames. iLoc uses integers. Loc uses what the actual label is. But I think the thing that I kind of struggled with is it column rows or rows columns? Just always remember rows, comma, columns. Which rows do I want? And then specify which columns do I want. Yeah, any questions or anything? I see something in the chat. Where do you store the Jupyter notebooks used during lectures? So for the Jupyter notebooks during that I'm doing right now, I included in the description of the YouTube video. So sometime today, I'm gonna finally try and get all my recordings up on the homepage, and the description will be in the home. We'll include the GitHub. We'll include the link to the GitHub.
They're super helpful. They're super helpful, and I'm new to the cohort, so include me if you don't mind separately in Slack until I get shifted. Thank you.
But yeah, just as a reminder for the people in my cohort, the part-time 10-7 cohort, I'm going to be on vacation the next 3 days. So if you have questions, post them in the main Slack channel, as I will not be responding to them very, very quickly. The other instructor, James, is here this week. He'll be responding to questions, and there's another instructor that's going to be kind of taking a look at some of the taking a look at the Slack channel as well. So that's all that I have. I have another call that I got to jump on. I think it's with David. Is that right?
I don't think so. But were we scheduled this week?
Yeah. I'm showing a one-on-one with you right now.
Okay, well, I can stay on if you need me to.
Yeah. Let's chat for a little bit, if that's all right, if you're free. But
super helpful. Thanks, Jeffrey.
Yeah. Have a good rest of the day, everyone.
Okay, I'm here, Jeff.